Here's a sentence that shouldn't be possible. The machine everyone said China could never replace, the one tool the entire chip industry insists is non-negotiable, might have just been quietly written out of the equation. No new smuggled hardware, no secret shipment, no loophole in the sanctions list. Just an announcement from a boardroom in Shanghai that made semiconductor engineers around the world stop scrolling.
If you followed the chip war even a little, you know the one machine that matters more than any other. It's called an EUV lithography machine, and exactly one company on Earth builds it, a Dutch firm called ASML. Without it, you cannot carve the tiniest, most powerful transistors known to physics. Every advanced chip inside your phone, your laptop, the servers training the world's AI, all of it traces back to that single machine, sitting in exactly one country's export control list. And China is banned from buying it. Full stop. Has been for years. So when Huawei announced this year that it had found a breakthrough letting it build cutting-edge chips within 5 years, explicitly framing it as a way to get around the very restrictions meant to box it in, the obvious question is the same one everyone always asks about these stories. Is this real, or is this theater?
By the end of this video, you'll understand exactly what Huawei claims to have built, why it deliberately avoids the machine everyone thought was mandatory, why some analysts are calling it genuinely significant, and why others are telling you to slow down. Let's start with the wall itself. For the last decade, the story of the global chip race comes down to one brutal fact. US sanctions have largely cut Huawei off from global chip makers, and Washington has also restricted Beijing's access to chip design software and the manufacturing equipment needed to shrink transistors further. That's not a minor inconvenience. That's the entire playbook the West bet on. Starve China of the one machine that makes progress possible, and the gap simply can't close. And for a while, it looked like it was working. China's most advanced chip making is currently thought to sit around 7 nanometers, while Taiwan's TSMC is already mass producing at 2 nanometers. On paper, that's not a gap, that's a canyon.
So here's where it gets interesting. Instead of trying to sneak around the export ban to get the same machine everyone else uses, Huawei's semiconductor chief stood up at a conference in Shanghai and said, in effect, we don't need it anymore. Rather than shrinking transistors through extreme ultraviolet lithography, the exact machine China can't buy, Huawei says it's folding traditional flat circuits into vertical, three-dimensional stacks, essentially building chips upward instead of squeezing them smaller. They're calling it LogicFolding. Think of it less like shrinking a city's buildings and more like giving up on shrinking them entirely and just building skyscrapers instead. Different problem, different solution, same destination.
And they didn't stop at one announcement. Huawei also unveiled something it's calling the Tau scaling law, its own theoretical framework for how chip performance can keep improving without needing smaller transistors at all. That's a bold move. Moore's law has run the entire industry's expectations for 50 years. Proposing your own replacement law is the kind of thing you only do if you're trying to change what keeping up even means.
Now, before you get too excited, here's the honest part, the part a hype video would skip. Huawei didn't release any independent performance data to back up the announcement. No third-party benchmark, no verified chip in hand, just a promise and a roadmap. And the roadmap itself is a long one. Huawei says it will start producing chips at the 1.4 nanometer equivalent density by 2031, while TSMC has already said it plans to be mass producing that same node 3 years earlier in 2028. So even if everything goes exactly to plan, Huawei isn't catching up. It's promising to arrive at today's frontier a few years after everyone else has already moved past it.
One analyst put it carefully. The Tau scaling law looks like the first real attempt by a Chinese company to turn these ideas into a coherent theory, and it may give the whole domestic industry a new reference point for getting around process node limits. Not proof of victory, but proof of a serious, coordinated attempt.
And this isn't happening in isolation. Zoom out and the pattern should feel familiar by now. NVIDIA was actually granted a license to sell its capable H200 chip to China back in February, and still hasn't shipped a single one, because Beijing has been quietly steering domestic companies toward homegrown alternatives instead. Even NVIDIA's own CEO has admitted the strategy might be backfiring. Jensen Huang said conceding a market the size of China probably doesn't make a lot of strategic sense, and argued that China's cheaper energy and enormous pool of AI talent mean cutting off hardware doesn't actually cap what the country can build.
Meanwhile, the raw materials story tells the same tale. Chinese wafer makers held roughly 3% of the global silicon wafer market a few years ago. By 2025, that share had already climbed to around 28%, and it could reach 32% by the end of this year. That's not a company getting lucky. That's an entire supply chain being rebuilt one link at a time, specifically so no single export ban can choke it again. So, does LogicFolding actually work? Nobody outside Huawei can say for certain yet. But here's the honest framing, the one you won't get from the headline. This isn't really a story about whether one chip architecture pans out on schedule. It's a story about a country that got told you can't have the tool, and instead of spending the next decade trying to steal a copy, decided to question whether it needed the tool's job done the same way at all.
Whether LogicFolding hits its target in 2031 or slips to 2033 almost doesn't matter for the bigger point. The strategic message is the same one we keep seeing across chips, materials, and now architecture itself. The chokehold everyone assumed was permanent might just be something you route around, given enough time and enough pressure. And that's the question worth sitting with. Was cutting China off from EUV machines a smart way to slow the country down? Or did it just force an entire industry to stop thinking in the same terms as everyone else, permanently? If you want to keep following where this goes next, the chips, the workarounds, the moves nobody's talking about yet, subscribe to Empire of Tech, and I'll see you in the next one.